Hi everyone, I am Mas with Victor. Kindly follow, like, and share my Facebook page with all your friends, and also subscribe to my YouTube channel. Today, we want to solve this very easy problem. We have a diagram and we are asked to find the value of angle X. So when you look at the diagram very well, you will notice that this is a straight line and this is also a straight line. Whenever two straight lines intersect or crosses each other, they produce what we call vertically opposite angles. And vertically opposite angles are equal. Therefore, x is equal to 65 degrees. Answer. Reason, x is vertically opposite to 65 and they must be equal. The same reason, this angle here must be equal to this angle here. But I want you to note very clearly that vertically opposite angles are formed whenever two straight lines intersect. It is different from having this and this. If here is 65 and here is x is not equal to 65 degrees. Take note. Why are they not equal? Because this and this are not vertically opposite. Why? This is a straight line and this is not a straight line. So vertically opposite angles are formed whenever two straight lines intersect. Hello, good everyone. Welcome to Maths with Victor. I am still your tutor. Please kindly like, follow, and share my Facebook page to all your friends, and also subscribe to my YouTube channel so that you can enjoy my amazing contents. Today, I want us to look at measures of central tendencies. Measures of central tendency. In statistics, when we talk about measures of central tendencies, because of the root word central, we are looking for the central score or central number that can represent the entire number or the entire scores in the distribution. I'm going to explain that very well. As your tutor, for instance, if I have 11 students in my class and I give out a quiz or a test or assignment, at the end of the exercise, I'm expected to have 11 scores. And on the board, I have 11 scores of my students after a particular test. So someone scored 8, 4, and so on and so forth. Now, it doesn't make too much sense if because somebody scored 1, I enter the class and I punish everybody. Does that make sense to you? Of course not. Why? In as much as there is somebody that scored 1, there is also someone that scored 10. What this means is that 1 as a particular score out of these scores cannot represent the entire students. Similarly, because somebody scored 10, it doesn't make sense also if I enter the class and I reward everyone because I have a student that scored 10. Why? Because in as much as someone scored 10, there is also somebody that scored 1. So I cannot reward 1 for the score of 10. But if I want to describe the entire students with one particular score, one single score that can be at the center and then describe everyone, I am going to apply any of the known measures of central tendencies to get one score that can represent all the scores. And in maths, we have 3 measures of central tendencies. We have number 1, the mean. Number 2, the median. And number 3, the mode. These are the 3 measures of central tendencies: the mean, the median, and the mode. Each of these measures will give you one score that can represent the entire score. So quickly, I will start with the mean. When we talk about the mean in its basic form, we are talking about adding all the scores and dividing by how many they are, the total number of scores. So when I do that quickly, I have 8 plus 4 plus 2 plus 10 plus 7 plus 6 plus 5 plus 6 plus 1 plus 6 plus 7. You add all the scores together, you divide with 11 because there are 11 in number. That is the mean. So quickly I will add them together. 8 plus 4 is 12, plus 2 is 14, plus 10 is 24, plus 7 is 31, plus 6 is 37, plus 5 is 42, plus 6 is 48, plus 1 is 49, plus 6 is 55, and plus 7 is 62. So I have 62 over 11. When you add all the scores, you have 62. Then you divide by 11. This will give me 5.5 5.63 in 2 decimal places, 5.63. So instead of describing this class with 10, which was the highest score, or describing it with 1, which was the lowest score, I can describe the class with 5.63 because 5.63 is a central score that can effectively represent all the scores in the class. That is the mean, a central score that can represent the entire score. The next measure of central tendency is the median. The median is just picking out the number or the score at the middle of the distribution. But very importantly, before you pick out the one at the middle, you must arrange the scores in order from the smallest score to the highest score, or from the highest score to the smallest score. So quickly I arrange the scores from the smallest to the highest. The smallest score there is 1, and I have 2, I have 4, I have 5, I have 6, 6, then I have 7, I have another 7, I have 8, and I have 10. These are all the scores when they are arranged in order. Remember, there are 11 in number, so to pick out the one at the middle, I will take out 5 from here, take out 5 from here, and I'm left with this at the middle, 6. That means 6 is the central score that can represent the entire score. So 6 is the median, the one at the middle when the scores are arranged. Finally, the last measure of central tendency is the mode. By definition, mode is the one that has the highest frequency. What that means is that mode is the one that occurs the most. So you look at the scores, you can see 8 is just once, 4 is once, 2 is once, 10 is once, 7 is twice, 6 is 3 times, 5 is once, 1 is once. That means mode is 6 because 6 has the highest occurrence. 6 appeared the most, more than any other scores. So by this now, we can describe the entire class with 6 as the mode. It's a central score that can represent every score there. We can also describe the class with 6 as the median, central score that can represent all the scores. We can also describe the class with 5.63 as the mean, central score that can represent all the scores. More often than not, the mean, median, the mode, they always give similar answers. Not necessarily exact, but something similar because each of them is a measure of central tendency. So it's very important in statistics, a single score, a central score that can represent all the scores. So quickly, I'm going to leave you the scores of 7 students in a math test. Quickly find out the mean, the median, and the mode. So out of 7 students, 1 scored 10, 1 scored 8, 1 scored 2, 1 scored 4. I have 6, 1, 2, 3, 4, 5, 6. Then I have 3. These are the scores of 7 students in a test. Quickly find out the central score that can represent all the scores. You can use the mean, you can use the median, you can use the mode. Thank you. Hello, good day everyone. Welcome to my class, Maths with Victor. Please kindly subscribe to my YouTube channel so that you can enjoy my maths content, amazing mathematics content. Also like, follow, share my Facebook page to all your friends and to all high school students so that you can enjoy my content as well. Welcome. So today we want to look at equations in irrational forms. Equations in irrational forms. And the first point I want you to note very clearly is that in any mathematical equation, there is always the presence of an unknown denoted by any letter of the alphabet. And to solve an equation means we are looking for the numerical value of the unknown. This means that we want to find out which letter, which number the letter is representing. So for what we have here, we have square root of x squared minus 7 equal to 3. So we are looking out for the number that x is representing so that this mathematical statement becomes true. So how do we solve for x? How do we look out for x? We need to eliminate everything here so that we are left with x at the end of the day. So we start by eliminating the square root. But the biggest question, how do we eliminate square roots? In mathematics, to eliminate square roots, we look for the inverse operation of square roots. And the inverse operation of square root is the square, which means squares eliminate square root. The converse is still correct. Square roots eliminate squares. Just like the cubes and the cube root, the raised to the power 4 and the 4th root, the raised to the power 5 and the 5th root, and so on and so forth. So to eliminate this square root, I will start off by squaring this quantity so that this square eliminates the square root. But there's something very important I want you to note. In any equation, we are always comparing two things. First, at the left-hand side, then at the right-hand side. And we are saying that this quantity is equal to this quantity here. So while solving an equation, there is always a need to maintain equality. For instance, I have two markers here, and I say that this marker is equal to this marker in size or in weight or in height, whatever. That is true. And then all of a sudden, from nowhere, I introduce something else to this marker. Possibly, I added 10 to it. The moment I add 10 to this marker, they are no longer equal because what I introduced here, I did not introduce here. But that is wrong because if I want to maintain equality, whatever I do to this one, I will do to this. So if I add 10, they are still equal. If I remove 20, they are still equal. If I divide by 2, they are still equal. So the moment I introduce something that was not there originally, square, to the left-hand side, I must also introduce it to the right-hand side so that the equation remains balanced. That is very good to note. So we call that to square both sides of the equation. Where we needed to square originally was the left-hand side, but to maintain balance, we must also square the right-hand side. So at this point now, this square, we eliminate the square root, and we are left with s squared minus 7 equal to 3 squared is equal to 9. Please note very well that 3 squared means 3 times 3. You multiply 3 by itself in two places. A lot of times people mistake 3 squared to be 3 times 2. That is very wrong. So 3 squared gives us 9, and we are here right now. So what do we do again? We are looking for x, remember. So we need to eliminate minus 7 by taking it away from here to the other side of the equation. That's what we call collecting the like terms, because 9 and minus 7 are numbers. So move all the numbers to one side of the equal sign. And mind you very clearly, or note very clearly, that anytime a quantity moves from one side of an equation to the other side, the sign of the quantity changes from minus to plus, from plus to minus, as the case may be. So we have minus 7. I'm going to move it away from here. S squared remains S squared. It didn't move anywhere. It's equal to 9 was at the right-hand side. It remains 9 at the right-hand side. It didn't move anywhere. So minus 7 moves from the left-hand side to the right-hand side. It changes to plus 7. Very important. Minus changes to plus. If it was plus, it changed to minus. So we can simplify this further to have s squared is equal to 9 plus 7 is what? 16. But mind you, we are looking for x, not x squared. So the next question, how do we eliminate square? Like I explained here, the inverse is square root. So you square root here, but you must also square root here. So this square root eliminates the square. We are left with what? X is equal to, what is square root of 16? Square root of 16 is plus or minus 4. That means the x here as a variable is representing either plus 4 or minus 4. And whenever you are done solving any equation, you can always check whether you are right or wrong by going back to the original equation, which was square root of s squared minus 7 equal to 3. When we go back to the original problem, we remove x and replace with the value we got. Remember, we got two answers, plus 4, minus 4. So to check whether we are right or wrong, we replace x with plus 4. When we do that, plus 4 squared means 4 times 4, that is 16. 16 minus 7, that is 9. And square root of 9 is 3. That means plus 4 is correct. We can also check for minus 4. Minus 4 squared means minus 4 times minus 4, which is still 16. 16 minus 7, 9. Square root of 9, 3. Minus 4 is still correct. So to solve this equation, the answer is either plus 4 or minus 4.